Hi and welcome to Polynomials Day 3. Today we're going to talk about division. But first we're going to multiply before we divide. Multiply these polynomials using the tabular method. So draw your boxes. 2x and 5, and then x squared, 5x and 1. And when we do our multiplying, we'll have 2x cubed, and then 5x squared, and then here we'll have 10x squared, and here we'll have 25x, and then here we'll have 2x, and here we'll have 5. And then on my diagonals, I will have 2x cubed. On this diagonal, I will have 15x squared. On this diagonal, I'll have 27x, and then over here, I will have 5. So my answer is 2x cubed plus 15x squared plus 27x plus 5. So what we have up here on the top is a factor times another factor, and that equals the product. So those terms should be familiar to you, factor, factor, product. When we divide, we had the dividend and the divisor, and it's equal to the quotient. Okay, so those are the parts of a division problem. How can you use the expression in part A, which is the one right up above us, to quickly multiply 25 times 151? Well, if you go back and you look at the actual problem, it was 2x plus 5, and then x squared plus 5x plus 1. Those coefficients match with what we have here, 25 and then 151. And if I go back and I look up here, if I were to put a 10 in place of x, that would give me a 20, and then 20 plus 5 would give me 25. And I'm going to do that. So sub in 10 for x. So I'd have my answer 2 times 10 cubed plus 15 times 10 squared plus 27 times 10 plus 5. So 10 cubed is 1,000, so this becomes 2,000 plus 10 squared is 100 times 15 is 1,500 plus 27 times 10 is 270 plus 5. And then if I add all those up, I get 3,775. So in other words, I just used the polynomial, the answer up above, to multiply 25 times 151. All right, next page. So does 2x cubed plus 15x squared plus 27x plus 5 divided by 2x plus 5 equal x squared plus 5x plus 1? Justify your answer. Well, we are going to do what we call the reverse tabular method. We are dividing by 2x plus 5, and our answer before we multiplied, we wrote all along the outside of our box. So if we were to add them up, this would have to be 2x cubed Coming down this diagonal would have to be 15x squared. Coming down this diagonal would have to be 27x. And then in that box would have to be 5. So I need to figure out what my answer is. So I know that this box here has to be 5 because it's being multiplied. It's adding to, nothing's being added to it. If you look at this box here, nothing's being added to it. And this box up here has to be 2x cubed, again, because nothing's being added to it. So then I have to ask myself, what do I multiply 2x by to get 2x cubed? Well, I already have the 2, so that means I need to multiply it by x squared. So x squared times 5 is 5x squared. Now this diagonal here, here, and here needs to add up to 15x squared, which means this piece here has to be 10x squared, because that's the only way I can get 15x squared if I have a 5x squared. So then I ask myself, what do I multiply 2x by to get 10x squared? Well, that's a 5x. And then I multiply 5x times 5, and I get 25x. Now this diagonal here needs to add up to 27x. I already have 25x, so that means this has to be 2x. And what do I multiply 2x by to get 2x? Well, that's 1, and 1 times 5 is 5, so that works out. So did it work? Did I get the answer that they asked for? The answer to that is yes. Don't worry, I'm going to do that again. Describe the process you used to determine your answer to the exploratory challenge. First thing we did was a table and label what you know. Label parts known. The second thing we have to do is the top left box. Like what goes in the top left box. Then 3, find the bottom right box. And then 4, fill in missing parts. Okay? So the reverse tabular method. You want to reverse the tabular method of multiplication to find the quotient. 2x cubed plus x minus 10 over x minus 2. Everything is already labeled for us. So to find the top left box, this has to be 2x squared. The bottom right box has to be negative 10. And now I just need to fill in what's missing. Well, what did I multiply x by to get 2x squared? Well, that would be 2x. 2x times negative 2 is negative 4x. There we go. And then I need that to add up to x, but I have negative 4x, which means this has to be a positive 5x. And what did I multiply x by to get 5x? Well, that would be just 5. 5 times negative 2 is negative 10. Check it out. So my answer is 2x plus 5. All right. Test your conjectures, create your own table, and use the reverse tabular method to find the quotient. Oops, and I seem to be missing the problem. Did it go on the next page? Yes, it popped onto the next page. All right. In your paper, it's not that way, so I will just rewrite it. So we have x to the fourth plus 4x cubed plus 3x squared plus 4x plus 2 all divided by x squared plus 1. All right. The one thing we need to make sure of is that we always have places for every variable starting from the highest power going all the way down. And I'll explain that a little bit more. So to figure out how you set up your table, the number of rows equals 1 more than the degree of the denominator. So in this case, my degree of my denominator is 2, which would mean I would need 3 rows because I need 1 more. The number of columns is 1 more than the difference of the degree of the dividend and degree of the divisor. So in this problem, if I were to subtract the 2 powers, the 4 minus the 2, I'd get 2, and I'd have to add 1 more, so I need 3. So on this problem, I need a 3 by 3. I know that this is x squared. I know that this is 1. So I have to have a place for 0x. And going around, this would have to be x to the 4th. This one would be 4x cubed. And this diagonal would have to be 3x squared. This diagonal here would have to be, sorry, it's just 3x. Yeah, 3x squared, so 4x. And then this one would have to be 2. So then I need to go back and do my division. My top left is x to the 4th. The bottom right is 2. So I'm going to go over here. X squared. Sorry about that. X squared. When I multiply x squared by to get x to the 4th, that would be x squared. So x squared times 0x is 0x cubed. Make sure you put the 0 in front, because if you don't put the 0 in front, that means there's a 1 in front. And then 1 times x squared is x squared. My last term here is 2. What did I multiply 1 by to get 2? Well, I multiplied it by 2. So x squared times 2 is 2x squared. And 0 times x squared is 2 times 0x is 0x. And this needs to add up. This diagonal right here needs to add up to 4x. So that means this diagonal right here, I need to have a 4x right there because 4x plus 0x is 4x. So I multiply 1 times 4x, give me 4x. So this should be 4x. 0 times 4x is 0x squared, and x squared times 4x is 4x cubed. So check your diagonals. 2x and 0 is 2, plus 1x is 3x squared. 4x plus 4x cubed plus 0x cubed is 4x cubed. So put a plus there because those are positive. And there is my answer. All right, next page. Test your conjectures here. Use the reverse tabular method to find the quotient. So my highest power in the denominator is a 2, which means I need 3 rows because I need to do one more than that. And then the difference of my highest power is 5 minus 2 is 3 plus 1 is 4. And this would be x squared, 0x, 4. And on the outside I have 3x to the 5th, negative 2x 4, 6x cubed, negative 4x squared, negative 24x, and then 16. This needs to be 3x to the 5th, and this one down here needs to be 16. What do I multiply x squared by to get 3x to the 5th? Well, that would be 3x cubed. So 3x cubed times 0x is 0x to the 4th. 3x cubed times 4 is 12x cubed. And then what do I multiply 4 by to get 16? Well, that is a 4. So 4 times 0 is 0x. 4 times x squared is 4x squared. So now I just work my way in on this diagonal over here where the x to the 4th is. I need to make sure it adds up to negative 2x to the 4th. Well, that means this needs to be negative 2x to the 4th. What do I have to multiply x squared by to get 2x to the 4th? Well, that's negative 2x squared. So negative 2x squared times 0x is 0x to the 3rd. And negative 2x squared times 4 is negative 8x squared. And to get 6x cubed, if I have 12x cubed, that means this and a 0x cubed, 12x cubed right here, 0x cubed, that would make this negative 6x cubed. What do I multiply x squared by to get negative 6x cubed, other than a 6x? Negative 6x. So negative 6 times 0 is 0x squared, and negative 6x times 4 is negative 24x. Check my diagonals. That one works, and that one works, and that one works, and that one works. So my final answer is 3x cubed minus 2x squared minus 6x plus 4. All right. What is the quotient of x to the 5th minus 1 over x minus 1? Well, my highest power in the denominator is 1, so I have to add 1 to that, so it's 2. So I'm going to have 2 rows. And my highest power in the denominator is 1. My highest power in the numerator is 5. 5 minus 1 is 4, plus 1 is 5. So I'm going to have 5 columns. 1, 2, 3, 4, and 5 columns. So this is x minus 1. And over here is x to the 5th, 0x to the 4th, 0x to the 3rd, 0x squared, 0x, negative 1. I have to represent all the powers from my highest power all the way down. This is going to be x to the 5th. This is going to be negative 1. What do I multiply x by to get x to the 5th? Well, that's x to the 4th. X to the 4th times negative 1 is negative x to the 4th. I need that to be 0x to the 4th, so this has to be positive x to the 4th. What do I multiply x by to get that? Well, x to the third. X to the third times negative 1 is negative x cubed. I need that to be 0x cubed on that diagonal, so that makes this positive x cubed. I multiply x by x squared to get x cubed. X squared times negative 1 is negative x squared. And this diagonal over here needs to add up to 0x squared, so that makes this positive x squared. X times what gave me x squared? Well, that's just an x. X times negative 1 is negative x. This diagonal here needs to add up to 0x, so that makes it x. X times what gives me x? Well, 1. 1 times negative 1 gives me negative 1, so that all works. So those are all plus signs. So believe it or not, those two little polynomials led us to this big, long polynomial for an answer. All right, one more problem. See if you can figure out the answer before I actually do it. If I have x to the 6 minus 1 over x minus 1, I'm still going to have two rows like I did in the one above. Except this time I'm going to have one more column because the degree from the 6 and the 1 is 5. Add 1 is 6. So 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. So this is x minus 1. This is x to the 6th, 0, x to the 5th, 0, x to the 4th, 0, x to the 3rd, 0, x squared, 0, x, negative 1. So my first box here is x to the 6th. What do I have to multiply x by? Oh, that's x to the 5th. X to the 5th is negative 1. It's negative x to the 5th. That has to add up to 0, so that makes this positive x to the 5th. What do I multiply x by to get x to the 5th? Well, x to the 4th. X to the 4th times negative 1 is negative x to the 4th. That needs to add up to 0 on its diagonal. So that will give me a positive x to the 4th up here. What do I multiply x by to get that? X cubed. X cubed times negative 1 is x, negative x cubed. That needs to add up to 0. X cubed on its diagonal, which means this is a positive x cubed. I'm going to multiply x by x squared to get x cubed. X squared times negative 1 is negative x squared. And then I need to make that diagonal add up to 0x squared. So it's positive x squared. X times what gives you x squared? Well, that's x. X times negative 1 is negative x. I have to have a 0x, which just means positive x. X times what gives me x? Well, that's a 1. 1 times negative 1 is negative 1. So everything adds up. So I'll put a bunch of plus signs in between because they were all positive. So my answer is x to the 5th plus x to the 4th plus x to the 3rd plus x to the 2nd plus x to the 1st plus 1. All right, and that is it. I hope you enjoyed First Tabular Method.